We've seen that because glucose has 4 chiral centers, there are actually 16 isomers. And of these 16 isomers, there are 8 pairs of enantiomers. So for example, this molecule here has a mirror image right here. So not of these 16 stereoisomers, there are 8 pairs of enantiomers which are mirror images. But what do we call the others? So stereoisomers that are not mirror images, are not enantiomers, are called diastereomers. So diastereomers are stereoisomers that are not exact mirror images. So let's look at D-galactose and D-glucose. So this is one of the stereoisomer pairs that are not enantiomers. So these two are diastereomers. So the 1 carbon is the same, the 2 carbon is the same, the 3 carbon is the same. And by same, I mean the arrangement and space of what is attached to it is the same. And then if we look at the 4 carbon, we see a difference. In glucose, on the Fischer projection, the hydrogen is on the left and the hydroxyl group is on the right. And that is opposite for D-galactose. So this is not a mirror image, but it is a stereoisomer. And let's look at D-talose and compare it to D-glucose. So one is the same and the carbon 2 is different. In glucose, the Fischer projection, the hydroxyl group is on the C2 carbon is on the right, and on the C2 carbon in D-talose, it's on the left. So for every single carbon, every chiral carbon in D-glucose, in D-galactose, and D-talose, every chiral carbon has 1 hydrogen and 1 hydroxyl. The 1 carbon and the 6 carbon are exactly the same. What's different is how they are arranged in space. And so if they're not mirror images, they're called diastereomers.